So today I was routinely looking through the Python Turtle module just to keep up to date, and I came across the usual on their front page of their Turtle documentation. I am in the Turtle section of the Python official docs, and this is all fine and good. But then I realized this is actually quite clever. So they let the little turtle move around, and then we just note it, say if the absolute position is minor than 1, that means I don't know where we're going. Just let me go until I am less than 1 pixel away from where I started, meaning I'm back. And I thought, well, that is actually quite clever. Can we do this in Snap? And it turned out we can. So I have my usual square screen here. My turtle, I positioned it down here. And it turns out that if I simply make a loop that goes on forever, this is the most simple approach. I start moving forward. So I move forward some amount, and you can see, wait, there is no stop right now. It's fine and good. But I turn the same 107 degrees as they did on the side. So let's refresh this, and you can see clearly the turtle just keeps on spinning because there's nothing stopping it right now except my anxiety level when these things happen. Well, so what we need to do is we need to put in, like when we do recursions, I am going to put in an if statement, and I am going to ask if, and then it turns out there's something called distance. Yeah. And let's just assume for now, just to take the very simple, let's just assume that the distance I want to stop is so now I'm starting from center, right? Because I just temporarily moved my initial jump. This is just for showing you the most simple, the basics setup. So what I can do is I can basically say, if my distance to center is, then stop this block. And then I just need to say that the distance should be minor than 1. The problem is when I start now, I'm at 0, 0 per default. So yes, when I am at 0, the distance is smaller than 1. So I am stopping before I get started. So what I need to do is I need to move the check under the actual instructions. So when I do it now, you can see, without knowing anything about how many times we need to do this, without anything clever calculations about angles and stuff like that, we basically just say, go amok, and when you get back home, then stop. And that is actually a quite sweet way of doing it. You can see how compact it actually is. It's actually really, really clever in some situations. So what if we then want to build on this and say, I want to move, be able to move, because we can't go back to the center all the time? Well, of course. So what we can do is we can put in a jump just for starters. So I push my turtle down here. Fine. But that means the chances of hitting the center is quite small. So, I mean, we have to improve on this kind of distance thingy. So what we can do is we can make, if you have push and pop installed, I do have push and pop. I actually have 2 different pushes. We can start by looking at the push. If you recall, basically puts a global it notes the location of where it is and puts it into a global call position, which is actually exactly what we need. So before we even start doing anything, we just say, where am I? I mean, after the jump, obviously. So what we can do then is we can say we go to a list of, we ask, where are we? If we are back to the first item of our list called position for the X, and we are back to the second item, because you can see the I value is here. And actually in the push and pop, we actually have, if you recall how it's actually looking, we also have direction, but we don't use this in this case. We might come back to that. But so now we can say, if it's smaller than our original position, the distance to center, that is, there you go. Then, so let's see what happens. So now we're down there. You can see our position has been updated, right? So I can close this one. And now, ta-da! It automatically stops when it is very close to under 1 pixel away from where we started. So in essence, it stops. So this is a great way, and I find it very liberating that I don't have to calculate how many times I need to. I will maybe go into a different video and I can show you about the least common multiplier. So, but for now, this is very nice.